Okay, so this is one of our large general purpose industrial ovens. We call that an LGP. It's got several interesting features, but if I just talk initially about the basic oven, this is an LGP2, which means it's 250 degrees C max, and it's a 1750, which that's the size of the chamber, 1750 litres. The extra features that you can see on this are we have a trolley with some rollers on and a tray for the customer to use to put their workpiece into the oven, and it has this great big gantry on the top which has an electrical door lifting mechanism so the door can be open and shut under electrical power. So this size of oven would normally have 18 kilowatts, that's the catalogue figure. In this case we've increased it to 24 kilowatts. That's because the customer is intending to have up to half a ton of steel parts on this tray which they load into the oven. The 24 kilowatts then speeds up the heating up process. So in this case it can heat up to 250 degrees C with an empty chamber in about 25 minutes, and then the additional heat needed to heat the steel parts would be about another 40 minutes worth of full power from those elements. It's a well insulated oven this, and so once it's up to temperature, the holding power needed to maintain 250 degrees C is about 15% of the maximum, so that's about 3.5 kilowatts. So this oven, as I said, has a mechanism to operate the door automatically. It's a nice, simple, robust industrial mechanism. In fact, this particular oven, this particular customer requested a copy of an oven we supplied to them about 14 years ago, which is still working fine, and they've asked that they're increasing production capacity, so they wanted another one the same. As you can see, the door is supported by two chains. They go up over rollers and connect to a counterweight inside this cover here, and there's an electric motor right at the top of the gantry which drives the chains, but because it's well balanced with the counterweight, there's not much strain on that motor. Because this oven has an actuated part, a moving door, we make it to satisfy the machine directive, so it has this emergency stop button here which would stop the door instantly if you press that. And we also make it so the door is operated by two independent buttons. There's a door enable button and then up and down buttons, and that means you need two hands to operate the door, and so you can't accidentally leave one hand underneath the door and suffer a nasty injury. So I'll operate this now. You see, to begin with it goes quite slowly, and then once it's cleared the opening, it goes significantly faster. At the top of its travel there's a limit switch, so it'll stop automatically once it's cleared the chamber roof. Like that. Now I'll press the down button. Door comes down again at it's relatively high speed. And we'll see as it gets nearly closed, it slows down there and then stops automatically when it's reached the closed position. This design just relies on the weight, the gravity, the weight of the door, and some simple guide rollers running on these guides to push the door inwards in the last part of the travel and to compress the seal behind, so it provides a good airtight seal around the door, which is very important to get good temperature uniformity. Okay, so now we've got the door open, we can see a few interesting things inside this oven. We've got a set of rollers inside which can accept the tray that has the workpiece on. Over this side we have a cover here, and behind that is this fan which circulates the air and the elements which provide the heating. When the fan's on, that blows air out of this slot here. It circulates generally horizontally through the oven and goes back in the slot at the back. We can also see the thermocouples which control the oven. There's 3 there just hanging down off the roof. 3 in this case. 1 is the main control thermocouple. The second one is the over temperature limit, independent over temperature limit, which can shut everything down if it gets too hot. And the third one, this oven is designed to meet the requirements of the aerospace AMS 2750E specification for heat treatment, and one of the requirements of that is to have an independent means of checking the accuracy of the control thermocouple. So the third one is known as a SAT, a Systems Accuracy Test thermocouple. Also in here we can see this frame. This is another requirement of the AMS aerospace specification. We use this for checking the uniformity of the temperature inside the chamber. You attach 9 thermocouples to this, 1 in each corner of the cube and 1 in the middle. Another feature you can see inside the chamber here, just here we've got a small port for passing thermocouples into the chamber. Very useful if you've got to do a uniformity test with 9 thermocouples. This is about 45mm diameter, and at the moment it's fitted with an insulated plug which prevents any real heat leak when you're not using it. So this particular oven meets plus or minus 5 degrees C temperature uniformity across the whole of this cube. That's a fairly normal spec for the AMS requirement. And it gets to plus or minus 5 at 250 degrees C after about 20 minutes. And in fact, if you leave it to stabilize for another half an hour or so, it can get to a 5 degrees C total span. So now we can see some details of the trolley and the tray. As I said before, the customer intends to put up to half a ton of metal parts on this tray, so the whole structure needs to be very substantial. And also we clamp the trolley to the oven using these screw-up clamps to make sure nothing moves during loading and unloading. The tray slides into the oven like that, up to its backstop in the oven, and then comes out like that. One other feature of this, the customer generally intends to leave the trolley up against the front of the oven. I think the parts will normally be brought in by crane, dropped onto the tray, and because of that we've designed this so that the door clears the front of the trolley in place. Other situations you might put the rollers further into the oven and have less of a gap, but in this case the door had to close with the trolley in place. So now we can see the control panel and the instruments. We have Eurotherm Nanodac as the main controller, and this is also acting as a recorder, which is one of the requirements of the aerospace AMS 2750 spec. We're just using one channel of that for recording the control thermocouple in this case, but it actually has 4 recording channels. So at the moment the other 3 are spare. The customer can use them if desired. This Eurotherm 3216 is the over temperature controller. That shuts things down if there's a fault and it gets too hot. And then we can see below those a set of sockets for the thermocouples. This is another requirement of AMS 2750. Each of the thermocouples going into the instruments has an in and an out connection, and that allows you to, if you take this link out, you can independently check the accuracy of the thermocouple by plugging in a separate instrument, and the accuracy of the instrument by plugging in a simulating voltage. And you can see here, this is where the separate systems accuracy thermocouple comes out. The customer would have their own instrument for taking a reading from that to check the accuracy of the other 2. And then over here we have the spare sockets connecting to the recording channels on the nanodeck. So now we can see inside the control cabinet. I can point out a few features here. Up at the top we've got the tail ends, the power connections to all the heating elements. Each one of those comes through a brass gland which fixes it firmly in place, and they're under these perspex covers. This is the motor which powers the circulation fan, 1.5 kilowatt motor, and just next to that you can see 2 inverters which allow us to adjust motor speed. So the bigger one connects to the fan. It's useful to be able to adjust the speed of that to tweak the temperature uniformity, and the smaller one controls the speed of the motor at the top that's lifting the door up and down. Over this side, the backs of the controllers and the switches and lights of the front panel. Over here, 2 solid state relays which are regulating the power to the elements, and this is the incoming mains filter. We've also got a alarm sounder which will go off if there is an over temperature incident, and over here a transformer. We step down the power to 110 volts for the internal electronics.